Lesson 10-5, probability and the addition rule. To find the probability that one event occurs or another event occurs, you must know how the two events are related. If two events cannot happen at the same time, they are said to be mutually exclusive. So just think X means separate or out. So they don't have anything in common. That is, the two events have no outcomes in common. One way to find the probability of two mutually exclusive events occurring is to examine their sample space. When a die is rolled, what is the probability of getting a 3 or a 4? From the Venn diagram, you can see that there are two outcomes that satisfies this condition, 3 and 4. The probability of 3 or 4 is 2 out of 6 or 1/3. Notice that this is the same probability that can be found by adding the probabilities of each simple event. Probability of getting a 3 is 1 out of 6. Probability of getting a 4 is 1 out of 6. 1/6 plus 1/6 is 2/6 or 1/3. So that would be the addition rule for probability. So again, formula you would use probability of A plus the probability of B for mutually exclusive events. Example 1, a card is drawn from a standard deck of 52 cards. Determine whether the events are mutually exclusive or not mutually exclusive and explain your reasoning. So drawing a 3 or a 2, that cannot happen at the same time, so this is mutually exclusive. For the reasoning, we'll just say separate cards. Drawing a 7 or a red card, this is not mutually exclusive because you can have a 7 red. Drawing a queen or a spade, this is not mutually exclusive because you can have a queen spade. Next, a date is chosen at random from a calendar. Prove whether the events are mutually exclusive or not mutually exclusive. Explain your reasoning. So choosing a date in the 3rd or 4th week of January. Those are mutually exclusive. They are separate dates. Choosing a Wednesday or a Thursday, those are mutually exclusive. They are separate days. Choosing the 13th day of a month or the first Monday of a month. That would be mutually exclusive because the first Monday of the month is not going to be the 13th day of the month. So separate days. Next, example 2. Daniel organizes all of his social media contacts into 3 groups. If the program sends Daniel an update from a randomly chosen contact, what is the probability that the contact is either a close friend or an acquaintance? So it says he has 68 close friends and 24 acquaintances. And then there are 10 that are restricted. So for mutually exclusive events, probability of A plus the probability of B. Probability of A is close friends, so that's 68 out of 68 plus 24 plus 10. That will give us 92 plus 10 is 102. So 68 out of 102 are close friends. 24 out of 102 would be acquaintances. If I add them together, this would give me 92 out of 102. Simplify this by dividing this by 2 halves, and this will give us 46 out of 51. So we would have 46 out of 51 chances. If you put that as a percent, that would give us 46 divided by 51 gives us roughly 90%. Next, the circle graph shows the percentage of new jobs in STEM fields by area through 2018, according to the U.S. Board of Labor Statistics. What is the probability that a random search on a STEM job board would result in mathematics or life science jobs? So out of all these, this is out of 100%. So what percent is mathematics? Mathematics would be 2%. And out of 100%, how many of them are life science jobs? Life science would be 4%. So if you add that, that would be 6 out of 100%. So that would be 6%. And I can reduce this by 2 halves. This will give us 3 out of 50. So 3 out of 50 would be 6%. Next, of the more than 79,800 species on a red list of threatened species, seabirds are of particular interest because they are indicators of broader marine health issues. This photograph shows the proportion of seabird species in each red list category. What is the probability that a randomly selected species of seabird is on the critically endangered list or the endangered list? So that would be 100%. So the critically endangered list, critically endangered is 17.5, or that'd be 5%, plus the endangered list would be 9%. So that'd give us 14% overall. If you did the numbers, so I would just leave it, I would just keep it as percent. That would be easier. Otherwise, if you had to add up all the numbers, 35 plus 49 plus 31 plus 17 plus 3 plus 4 plus 207, then do all that math there. It'd be easier just doing the percent. So 14%. Next is dealing with not mutually exclusive. If two events can happen at the same time, they are not mutually exclusive. When a die is rolled, what is the probability of getting a number greater than 2 or an even number? From the Venn diagram, you can see that there are 5 numbers on the die that are either greater than 2 or an even number. So that's 2, 3, 4, 5, and 6. So the probability of getting a number greater than 2 or even is 5 out of 6. Because it's possible to roll a number that is greater than 2 and an even number, these are not mutually exclusive. So the formula for this one would be probability of A plus probability of B minus the probability of both. And here you can see that formula here. Here you only use this for not mutually exclusive events. So our first example, not mutually exclusive, says a game piece is selected at random from a plate at the right. What is the probability that the game piece is round or orange? So for round, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shapes. Ones that are round are 1, 2, 3, 4, 5. So 5 of the 10 are round. How many of them are orange? There are 1, 2, 3, 4 of the 10 shapes are orange. Then we have to take out the ones that are orange and round. That's 2 out of the 10 that are round and orange. So if I do the math, that's 9 minus 2 is 7. 7 out of 10. So we would have 7/10. Or you can write it as a percent, which would be 70%. Next, a random number from 1 to 100 is generated. Find the probability of each set of events. So the probability of odd or greater than 50. So there are, out of 100 digits, there are 50 numbers that are odd, because if 50 are odd, 50 are even, plus how many are greater than 50? There will be 50 numbers that are greater than 50, and then we have to subtract 50, because 50 are the numbers odd and greater than 50. Actually, it wouldn't be 50, it would be 25 here. Because there are 50 odd ones that are, or there are 50 greater than 50 numbers, but out of those 50, only 25 of them are odd. So if I do the math, this gives me 75 over 100, which gives us 3 out of 4. 3 out of 4 are both odd or greater than 50. Divisible by 2 or even. So divisible by 2, that means your half of the numbers are divisible by 2, plus half of the numbers are even, minus out of the ones that are even, all of them are divisible by 2, so I divide that by, minus by that by 50, I end up with 50 over 100, which is equal to half. So half of the numbers are divisible by 2 and even. And letter C, prime or 2. So there are 25 numbers that are prime, plus 1 out of 100 is 2, and 2 is prime. So if I subtract that out, I'm left with 25 over 100, which is 1 out of 4. In our last problem, polygon is chosen at random. Find the probability of each set of events. So choosing a figure that has more than 4 lines of symmetry or more than 7 sides. So we got, there are 8 polygons or 8 figures here. 4 lines of symmetry. So 4 lines, that would be, there's 1, 2, 3, 4. There's 1 there. This would be 1, 2, 3, 4, 5, 6. That has more than 6. Let's see. This one could be that would be more. So more than 4 lines of symmetry. Triangle has 3. This has 4. Everything else has more than 4. So this would be 5. 1, 2, 3, 4, 5, 6. So 6 out of it would be 6 because this one doesn't have more than 4 lines of symmetry. This would only have 1 line of symmetry. So that would be, this one has 4 more. So this would be 1, 2, 3, 4, 5. So 5 out of the 8 has more lines of symmetry, more than 4 lines of symmetry. And then this one has 6 sides, so 7 sides, 8, 9, and this has 10, so more than 7. There's 3, plus 3 out of 8, and then 2 out of the 8 have more than 4 lines of symmetry and are have more than 7. That would give us 6 out of 8, which gives us 3/4. Choosing a figure that has more than 15 diagonals or a total interior angle measures greater than 900. So more than 15 diagonals. So find the 15 diagonals. Triangle has 0. This one has 1, 2. This one will have 1, 2. 2 times we have 1, 2, 3, 4, 5 corners, so that would be a total of 10. This one would have 1, 2, 3. 3 for every every corner. So we have 1, 2, 3, 4, 5, 6. That's 18. This one has 1, 2, 3, 4. 4 times 7 is 28. This one has 1, 2, 3, 4, 5. 5 times 8 is 40. This one has 1, 2, 3, 4, 5, 6. 6 times 9 is 54. This one will have 1, 2, 3, 4, 5, 6, 7. 7 times 10 is 70. So that's greater than 15 is 1, 2, 3, 4, 5. We have 5 shapes that are more than 15 diagonals plus interior angles greater than 900. We use the formula n minus 2 times 180. So this one has 180, this has 360. Here we have 5 sides, that's 3 times 180, that's 540. Next one, that's 6 minus 2, so 4 times 180 is 720. This one we have 7, 7 minus 2 is 5, 5 times 180 is 900. So more than 900, the 1, 2, 3, so plus 3 out of 8. And then the ones that are more than 5 diagonals, more than 15 diagonals, and is greater than, that's 3. So this would be 3 out of 8. Now I gotta go back to the diagonals because I forgot about the duplicates on there. So the formula for the diagonals we're going to use is n times n minus 3. And then we're going to divide that by 2, where n is the number of sides. So if I go back to that, so 3, so this one will not, this does not have it, this one will not have it, this one will not. If I had here, number of sides, I have 1, 2, 3, 4, 5, 6. So 6 times 3 is 18 divided by 2 gives us 9, so this one does not. This would be 7 times 4. Divide that by 2 gives us 14, so that one does not work. This one would be 8 times 5 divided by 2, that gives us 20, so yes, this one would be yes and yes. So then we would have total of 3. 3 plus 3 is 6, minus 3 is 3/8, gives us 3 out of 8, which as a percent would be 37.5%. And the last one, choosing a figure that has more than 2 pairs of parallel sides or at least one diagonal. So more than 2 pairs of parallel lines. So this one, no, yes, no, yes. This one, no. This one, 1, 2, yep. This one, no, and this one, yes. So that's 1, 2, 3, 4. 4 out of 8 plus at least one diagonal. If we use that formula for the diagonals, so this would be no. This would be 4 times 1 divided by 2. This would be a yes. This would be 5 times 2 divided by 2 is yes. Or yes, 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 yes. 1, 2, 3, 4, 5, 6, 7 out of 8. And then out of the ones that we said no before, diagonals. Let's see, for a parallel has more than 2. So let me see, this one has 1. This was a no. I gotta go back to that one again. So this was a no. This one is a no. Yeah, 1, 2, yeah, 3. So this one's yes. This one's no. This one's yes. This one is no, and this one is yes. So that's 1, 2, 3. Now going back to the last one, has at least one diagonal. Four times, yeah, so that would be all of those. So that'd be minus 3. Okay, so this will give us 10. 10 minus 3 is 7 out of 8. So 7 out of 8. Would give us 87.5, so that would be our correct answer. That is our lesson on probability and the addition rule.